Here's a simple challenge. Take exactly 4 copies of the digit 2, and using mathematical operations, make any natural number that you want. And note that you can't use any other digits. You can do a few examples with just addition, subtraction, multiplication, and division. If you add in exponents and factorials, you can generate more numbers. Now, looking at the rules, there's nothing stopping me from putting two 2's together and making 22. So we can generate 26, 11, and 444 quite easily. Now, there are some numbers that are notoriously difficult to get. One of these is 7. But, of course, if we allow ourselves sufficiently exotic mathematical operations, we can do it. For example, we can use something known as the gamma function. What's important is that this function has a very nice little property. Gamma of n is equal to n minus 1 factorial. So if we do gamma of 2 plus 2 plus 2 plus 2, that simplifies to 1 factorial plus 2 plus 2 plus 2, which is 7. The more math skills you have, the more numbers you can make. For example, 12 can be made by employing the complex numbers. The inside can be simplified as 2 plus 2i square root of 2. The squared magnitude of a plus bi is a squared plus b squared. So we get 2 squared plus 2 square root of 2 squared equals 4 plus 8 equals 12. So this is a fun little pastime, huh? Would be a shame if someone ruined it. In the 1920s, Paul Dirac was playing around with this game. You may know him a bit better for the Dirac equation, which was his attempt to reconcile quantum mechanics with Einstein's special relativity. He's also responsible for introducing the delta function into quantum mechanics, which, in addition to not technically being a function, had the terrible consequence of making physics majors think they could do mathematics. But let's return to the game. Look at what happens when you apply the square root to 2 over and over. You get a sequence of 2 to the 2 to some negative number. If the square root is applied n times, then you get 2 to the 2 to the negative n. If you now take the log base 2 of both sides, you get 2 to the negative n. And if you apply another one, and then move the negative over, well, you get a general formula for any n using only the digit 2. Now, you may note that on the right side of this equation, you have 3 2's. This is easy to amend, however. Since 2 equals the square root of 2 plus 2, we can replace any single digit with that and get 4 2's. Now, you may think that this is cheating, but actually it isn't. There's nowhere in the rules that says I can't do this. Also, the n doesn't actually appear anywhere. It just counts the number of repeated square roots. For example, we can write that pesky 7 as... So thanks, Paul Dirac. You couldn't have just let me have my whimsy, could you?